Hi guys, happy Thursday. I'm sure most of you were able to see the Blooms message I sent out to your parents. If your parents have not seen it, please check it out. It's going to give you guys some information on how we're going to start doing these lessons going forward starting next week. So starting next week, there aren't going to be so many of these videos that we're doing for you that we're putting on YouTube. We'll still do a few, but we're actually going to be doing some live virtual classroom type classes that we're going to be doing through Zoom. So be sure that you're looking into Blooms. Tell your parents to check Blooms every day, because we will be sending out a schedule of the times that you should be online to do these classes. If you do not have access to the computer to go online, don't worry about it. Okay, just send us a little quick message saying I don't have this access, and we'll find a way to get these videos to you. It'll be just like watching them on YouTube, except it's going to be a little bit more interactive between your teachers and the students that are there to participate. Okay, so anyway, back to today. We are working on word problem strategies. We are back in the packet. Okay, so for those of you, the last 2 days we have not been working in the packet. We've just been learning how to break apart a word problem and turn it into a tape diagram. Today we're back in the packet. All right, so we're going to do the first 3 problems in the packet together. The rest of them will be on you guys. All right, so let's get started. All right, so like I've been using before, I'm going to bring out my anchor chart again. This is really helpful when we're trying to decide what operation we're supposed to be using and how to set up those tape diagrams. So looking at the first problem, Brian has 80 golf balls. He put 32 golf balls into each of 2 bags and the remaining golf balls into a bucket. Use the strip diagram below to find out how many golf balls Brian put into the bucket. So the good news is they've already drawn out part of this tape diagram. So what I'm going to go ahead and do here on this very first problem is we're going to look in the problem itself and see how they got these numbers and why they chose to put them where they did in the tape diagram. So when we look here, I'll be using green for what we know, and the purple will be for what we do not know, what we are solving for. So he has 80 golf balls. This to me tells me this is a total. It's a total number that he has. 32 golf balls get put into each of 2 bags. All right, so this tells me this is going to be one of my parts, right? So of the 80 golf balls, 32 gets put into each of 2 bags. We'll get back to this in just a moment. The remaining golf balls are put into a bucket. All right, so looking at bags and bucket, why are these 2 things important? It tells us how many parts I'm going to need to solve for the total. So when I look here, and I'm just going to go ahead, they put this tape diagram into 3 parts. Where are those 3 parts coming from? Well, there's 2 bags, 2 bags, and a bucket. So I want you guys to be able to get in the habit of when you are reading through a problem, you see these things and you're already trying to figure out, okay, is this going to be part of the parts? Or if this is a multiplication or division problem, is this telling me groups or numbers of groups? So going back to this tape diagram, I know that he had a total of 80 golf balls. So that's where that came from. In the 2 bags, which we've already had drawn here, there are 32 golf balls. So 32 and 32, because it says it's in each of the bags. And we are solving for the unknown, which would be the number in the bucket. Okay, so we're solving for this right here. So just looking at this problem right here, the way we have it set up, I have 2 known parts, an unknown part, and I do know my total. What type of problem is this? Subtraction, right? In a subtraction problem, I know parts, I have an unknown part, and I know a total. So when we go to solve this, First, we need to figure out how much these are in total, right? Once we figure that out, we subtract the 64 from the 80, and it gives us our unknown part, which would be 16. Of course, when we're done with our problem, what should we always do? We should go back, plug in our numbers that we say are correct, right? Do the opposite operation to check for our answer. So if I were to add 32, then 16 together, we should end up with 80. So 6, 7, 8. Good news. It checks out. This has to be the right answer. All right, next question we're going over is question 2. So let's read it through. Sarah made 6 dozen cupcakes for a party at work. Some of her coworkers, C, okay, that tells me we have a variable, each ate 3 cupcakes. Now there are 45 cupcakes left. Which equation represents the situation? Remember, when it's just asking for an equation, we should always go ahead and solve for the actual problem, because when we draw up our tape diagram and we work through the problem, we can easily see which answer is right. So let's go through, figure out what we know and what we do not know. We know she made 6 dozen cupcakes. This would be our total, right? Some of her coworkers, C, each ate 3 cupcakes. So here, this is 2 parts, right? So what I don't know is how many coworkers. The C tells me this variable stands for an unknown number, and they each ate 3 cupcakes. And finally, there are 45 cupcakes left. So this is kind of like the problems we did yesterday where it was a multi-step. It's looking like it's going to set up the same way. So the first thing we need to do is try to turn this information into a tape diagram. So the first part's pretty easy. I know a total. It's 6 dozen cupcakes. So up here for the top on a total, I would put 6 dozen. If you want to go ahead and right here solve for what that is, you can go ahead and do that right now. Let's just go ahead and do that. We know that a dozen means 12. So since there were 6 of those, there are 72 cupcakes. So 6 dozen or 72 cupcakes total. Now, moving on to the next sentence. Some of her coworkers each ate 3 cupcakes. So what I'm kind of seeing here is the coworkers could be groups, and they each ate 3 cupcakes. So each coworker ate 3. To me, if this is a coworker and that person ate 3, it is showing me this is kind of looking like a division problem, where I know the number in each group would be the 3 cupcakes, but I don't know how many coworkers ate those 3 cupcakes. So what I would do here is just put a couple lines, because I don't know how many coworkers are total, and I put a 3 into each one of those groups, because that's how many cupcakes each one ate. Now we're getting to the last part of that problem, that there are 45 cupcakes left after those coworkers ate them. So I can block off an area over here to show what was left over after these coworkers ate their cupcakes. So now we need to figure out, what operation do we use first? We can't really solve for this yet because we don't know a total that only involves this part. These 72 cupcakes involves what the coworkers ate plus the 45 that are left. So when I look at a subtraction problem here, right, if I know one of my parts for sure, which is the 45 cupcakes that were left, and I know a total, my unknown part is this right here. So it looks like I need to subtract first. So if I take my 72 total and I subtract from 45, I'm left with 27. So this group right here, there were 27 cupcakes that were split by the coworkers. So now this problem is looking like a division. The total is now the 27 cupcakes. And I still don't know the number of groups or the number of coworkers, but I know each one had 3. So this tells me I need to divide 27 by 3 to figure out how many coworkers ate them. So 27 divided by 3, just a little practice doing long division. 3 cannot go into 2, right? So I can put a 0 there. Once you put a number at the top, we multiply out. 0 times 3 is 0. Bring down the 7. 3 can go into 27. How many times? 9, right? 9 times 3 is 27. This is going to make a mess for the next problem. So 9, there were 9 groups total. So you can go ahead and fill that in right now. So now that we've created our tape diagram here, we can go ahead and come up with an equation to answer what the actual question is asking. They're wanting an equation. So right here I have 3 times 9, or C coworkers, plus 45, and that gave me 72, or 6 times 12. So where do I have this information over here? Here it has C times 3. Well, yeah, I did have to figure that out. And it says I subtract 12. No, that can't be right. I never subtracted 12. Here I have 12 times 6. Yeah, I had to do that. Subtracting C times 3. Well, if I take this and I subtract this, couldn't I end up back here anyway? I could. So that's a maybe. C times 3, okay, yeah, equals 45. No, that's not right at all, right? Because we figured out what C was. It was 9, and it equals 27. So that can't be right at all. And finally, 12 times 6. Yeah, we had to do that to figure out how many cupcakes were made. Minus C. Well, we know that C equals 9. And 12 times 6 was 72. If I did 72 minus 9, I would get 63. So, nope, that's not right. So by actually solving out the problem, it makes this part so much easier. I know when we have multi-step problems like this, where they're not even looking for an actual answer, and we went ahead and solved it anyway to find an answer, it seems like we're wasting time, but in the long run, it's helpful because not only are you practicing solving these types of problems, when you go to find the correct answer choice, it is a lot easier to eliminate wrong answer choices when you know exactly what the answer is. Okay, going over question 3, you guys might want to read along in your packet or on Study Island since I drew over some of the words here. So Jackie had 50 cookies. She gave 6 friends 6 cookies each. Use the strip diagram below to find how many cookies Jackie has left over after each friend got 6 cookies. So just reading this problem, it reminds me a little bit of this one, right? Where we know a total, we know that Well, here they actually tell us the number of groups, whereas this one we didn't know number of groups, we only knew how much each person ate. And the only difference here is we don't know the leftovers, whereas here we knew the leftovers. So we know that this is going to be a multi-step problem that involves some multiplication and some subtraction as well. So if we look here, she had 50 cookies. Okay, that's our total. Put 50 cookies here. She gave 6 friends 6 cookies. So right here, the 6 friends tells me that's how many groups I'm going to have. 1, 2, 3, 4, 5, 6. Each friend got 6 cookies, so that's the number in each group. So 6, 6, 6, 6, 6, 6. What we do not know is how many she has left over. So that's what we're solving for, this part right here. So just looking at this, what's our first operation? What do we do first? If we turn this into a big part whole, this looks like a subtraction problem, right? Total, I know a part, I'm solving for an unknown part. So we solve for this part first, right? 6 times 6. 6 friends, they each ate 6 cookies. Total of 36 right here. So, known part, unknown part. We know the total, we know this is a subtraction problem. 50, take away 36, 14. So there should be 14 left. If we put this back in, 14, we add the 36, we come back to 50. So the biggest difference between these two problems as far as answering goes, question 2 is asking you to figure out an equation. All right, problems like this seem like they're going to be the easiest because you don't actually even have to solve the problem to answer a question. But if you don't go through and solve the problem, some answer choices might seem like they're right because we haven't set it up to see how many steps the problem is actually asking. So with this one, we had to do multiplication, we had to do some subtraction. Okay, same thing here, except we only had to answer the problem. And that's why I think questions like this are a lot easier, even though when you're looking at them, they seem a little bit more difficult. Okay, so that was today's lesson, solving word problems. I'm hoping after the past couple of days, you guys feel a little bit more comfortable with tape diagrams and how to take information from a word problem and turn it into a tape diagram. Again, this is very helpful, guys. If you want to just like make a copy, make it look really pretty, like I obviously did, go ahead and do that. It'll be really helpful. Tomorrow, we're going into lines, raised segments, parallel and perpendicular. So this section is actually pretty easy, but the hardest part about this is we have so much vocabulary. So what we're going to do is, if you guys have some paper lying around the house tomorrow, I want you to go ahead and fold it and tear it into like equal cards, equal size cards, and we're actually going to make some definition cards so we can play a game of memory. So I'm going to show you how to set that up tomorrow that you guys can do just to pass your time. It'll really improve vocabulary. I recommend it not just for math, but definitely for reading and writing and things like that. It really helps make learning vocabulary fun, but also helps memorizing it a lot easier. So we'll be doing that tomorrow, and then of course going through and solving some of these problems. Hope you guys have a good rest of the day.